Hello and welcome to the first lesson on finite element analysis with ANSYS. In this first lesson, I'm just going to be talking about the basic steps that one needs to take in order to do a successful analysis with ANSYS, and end up the first course with or the first lecture with a very basic example or model in ANSYS. And show you how you have to make your model, define the loads, and solve your model, and then read the results that you require. There are three basic steps that are required to do an analysis in ANSYS. The first one is called if my handwriting is okay, preprocessor, during which you define the element and real constants such as the cross-section area of your beam, for example, and you define the material, like whether it's steel or aluminum or any other material you want to test. And then there is a modeling step in which you define the areas and volume or any other thing that you want to design for your model. And then you do the meshing in the pre-processing step of ANSYS, which I will explain all of these steps briefly. And then you define your loads. This is the first step of doing a model in ANSYS. And the second step is called solution, which in this step also you can define your loads similar to this one here, and you can solve your model. And after you're done with your analysis, what you have to do is to read your results, which is under the general step, which is called general post process, during which you can read results. And you can output your results in terms of tables or graphs / plots, and also you can define paths and attribute special outputs such as, for example, stress, normal stress, shear stress, von Mises stress, or any other kind of results you're interested in. And you get or read the results for that specific path instead of reading the results for the entire model, which, if you have a bulky model, it's very convenient to have a path defined and read the results for a certain path of interest. So this is the first thing I want to talk about in ANSYS. So here, as I've said, you have to define an element. What is an element? Well, when you want to do an analysis in ANSYS, you need to define an element, which can be a beam, a length, solid material, all of this stuff. Or you can also define heat elements, electromagnet elements, physical elements. So basically, an element tells ANSYS, or says to ANSYS, what kind of analysis you are interested in. And then real constant, which I wrote real cross in here, it should be real constants, defines some attributes of the elements I just defined in the first step. For example, if you define beam as the element of your analysis, then you have to define the cross-sectional area of the beam, or the moments of inertia or stuff like that you have to define for the beam. And then the material, in the third, if I can find the material is defines the attributes such as elasticity and Poisson's ratio for the material you're going to be testing or you're going to be modeling and analyzing it in ANSYS. So basically you have to define these materials, because when you want to do calculations even by hand of, let's say, stress or displacement of a beam, for example, you need to have these constants such as I said, elasticity or Poisson's ratio. In the modeling section, you define the areas, the volumes, based on the geometry of your material or your model. You use this step, the modeling step, to draw your areas, your volumes, in case of a 3D modeling. And then you can apply loads on each side or face or node or anything else. And here comes meshing. Basically, ANSYS does its analysis or runs the analysis based on a node and element calculation. So when you're defining when you're doing your modeling in the modeling section, you're making areas, volumes, lines, and stuff like that, which ANSYS cannot do anything, cannot understand how to solve loading on a surface or an area or a line. So if you have anything but nodes and elements, you have to do the meshing to divide your, say, area or volume into a number of elements which are defined by some number of nodes, and then ANSYS can use these nodes and elements to do the analysis for you. Which again, if you want to delve deep into that, then in each element there are going to be some integration points that ANSYS uses to do the analysis, but this is very advanced into explaining how ANSYS really does the analysis. I'm just going to be staying in the simple side of the explanation and just tell you that there are nodes and elements that ANSYS needs in order to be able to do the analysis for you. And that's the task of meshing. So when you do modeling and you use and you create areas or volumes or lines, then you use the mesh to divide your model into a number of nodes and elements for ANSYS to be able to do the analysis. And then in the loads part of the preprocessor step of ANSYS, what you have to do is you define the loads in case of, for example, restraints. Let's say, for example, in this example, this is a beam, and imagine I have a fixed end in here and a load in here. So you define this strain and this load in the load section of the preprocessor. You can apply moments. You can apply pressure in terms of structural analysis. If you're doing heat transfer analysis, you can apply heat in, for example, heat flux, or you can define temperatures of each side. Let's say temperature on the right side and temperature on the left side, which I'm calling TO and TH, for example. Just basic things that you can define in order to do a heat transfer analysis. And then, as I said, in the solution step in ANSYS, you can also define loads. This is basically the same thing. Just you can change loads in any of these two steps, either in preprocessor step or the solution step. And there is the solve step solve sub-step in the solution step, that when you go through there, you can start solving the model that you have, solving the model and analysis that you have just made in ANSYS. When the solution is successfully done, you come to the general post process, which in this, if you're doing a static analysis, let's say just a very simple, like this example that I drew in here, and your load is just constant load, which is not changing by time, well, when you want to read the results, you're basically looking for the displacement in any point of this beam, the reaction forces in here, which are going to be in terms of F in X, F in Y, and moments in the fixed end, and probably stresses distributed around, along the length of the beam. And you can tabulate your results, or in other words, you can extract your results in terms of tables. You can also see the results in terms of graphs and plots, and if you have a model which is a little bit complicated, you can define path and attribute, let's say, displacement or stress in that path, and and read the results for that path. For this example, or for this lesson, I want to do a very basic analysis. If I can scroll down in here. Alright, for this example that I want to do today, it's going to be very basic. I'm going to have a beam and support it at two locations, or this is going to be something like this, and in the middle I'm going to apply a load of 1 kilonewtons. These lengths are going to be equal, let's say, in terms of 1 units, let's say 1 meters, or all of them. And then apply the 1 kilonewton load right at the middle of this beam and run the analysis. Basically, what I have to do is to define an element first. For this case, I'm going to be defining the element beam 3, which is a very basic element in ANSYS, which I've heard that some newer versions of ANSYS are not supporting beam 3 anymore. There is an alternative way, which I will explain later in future examples and tutorials. For this beam, which is going to be, for my case, I'm looking for a square cross section of 12 by 12, let's say, meters or units. I'm not gonna concern myself with the units. I'm gonna give 12 by 12 for the cross section area, which I will also need to define IZZ for in ANSYS when I'm defining the real constant, which is going to be BH3 over 12, which is equal to 12 times 12 to the 3 over 12, which is 12 to the 3, which I'm going to give to ANSYS. My material is going to be steel with modulus of elasticity of 200 gigapascals, which is equal to 2 times 10 to the 11, and Poisson's ratio of 0.3. And then the load is going to be 1 kilonewtons right in the middle, and I have Ux equals Uy equals 0 in here, and Uy equals 0 in here as my constraints for this model. And because this is a very basic analysis, I will only define 5 nodes, here, 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 and here. So I will only define 5 nodes, and I will have 4 elements. So this is my element 1, element 2, element 3, and element 4. The more elements and the more nodes you have in your model, the more accurate your analysis will be. So if I had, say, another element in here, or node in there, another node in here, one element in here, and or node, I'm sorry, and I had one other node in here, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9 nodes, and 1, 2, 3, 4, 5, 6, 7, 8 elements, which means my precision could probably increase by 100%. But for a basic model like this, it doesn't really matter if I have 4 elements or 8 elements, because this model is very, very simple to analyze in ANSYS. So I don't really concern myself with the number of elements in this model. Plus, the ANSYS that I'm using on my computer is a student version, which is limited to only 1,000 elements. So if I have a sophisticated 3D model and I want to mesh that very in a very fine meshing method, which may increase the number of my elements into more than 1,000, then my ANSYS will not solve it, because my ANSYS is a student version and limited to only 1,000 elements per analysis. So with this being told, let's switch to ANSYS and run the example. So here's the ANSYS, the area or the software as you see in here. And this section that you see is the general or the menu that you can, run some comments from here, such as clear and start new. So if you've already done a model and you want to start a new model, you just click clear and start new, and everything will be refreshed. You can change a job name. Let's say initially it's called file, so I can say ANSYS, let's say tutorial 01. And then you can also change a directory where you want to save your files. If you want to, I'm not going to be changing that. Change a title. I'm going to say ANSYS tutorial 1. And then if you have saved your job or your task before, you can resume it from that file, and you can save and read input files, which we'll delve into later. Select is where you wanna, if you wanna, let's say, select just certain nodes or elements or lines or areas which are hard to click by mouse. If you have special criteria that you can distinguish those desired or required, let's say, elements, then you can run these comments and select them, and then apply, let's say, loads or constraints in your selected line or element or area. And list in here, let's say you have done your models and you want to see how many areas you have or how many lines or key points you have. You can come here and select what you want. For example, if I click areas in here, it's going to tell me that there are no areas to list, because so far I haven't defined or I haven't done any modeling, or I haven't generated any areas in my model. So if I had anything, let's say if I had nodes or elements, I could list them in here. In plot, you can plot, after you've done with your modeling, you can plot your lines or areas or volumes if you need to look at them, and then plot control, which will come to them later. So basically, some of the simple comments that you will need to use or run during ANSYS, you can find them in here. But if you want to do your analysis, you want to use this section, which is ANSYS main menu, which contain the comments that you need to do to generate your model and run your analysis. So I'm going to start out with this first option, preferences. This is not really required. If you don't want to do this, it's okay. You can skip this step. But what this window gives you is the option to say, okay, just show me structural or thermal or structural and thermal options or features in the coming steps in ANSYS, and don't show me the ANSYS fluid and Flowtran CFD options or features, because let's say we don't want to do any fluid or thermal or CFD analysis. So if I keep this structural on and leave the rest of them unchecked, then everything that I will see in the future, let's say in the process of defining loads or selecting elements, they will be just the ones that are attributed to structure analysis, and the elements or loads which are dealing with thermal or fluid analysis will not be shown. If I uncheck this structural, then I will see everything. I will see elements and loads for thermal, structural, and fluid analysis in ANSYS. And also you have the option to do electromagnetic analysis if my ANSYS has them, which I've never looked, but if my ANSYS has these options as well, but I can also do electromagnetic analysis, which I'm not very interested in that area. So for now, I'm gonna click structural. As I said, this step is just optional. In some versions of ANSYS, this window pops up in the very beginning, but in my version, I have to run it from the ANSYS itself. So if I click OK, now I come to the preprocessor step, and here I can define the element, real constants, as I said, material properties and sections, modeling, meshing, and go on. So, and everything is in order. So if you want to do your analysis, you have to start from like top to bottom. So the first step is go and define the element type. So I come here, add my element, click add, and then I want to do a beam. So I find beam, a 2D elastic. I want to do an elastic modeling. I'm not going to be involved in plastic analysis, so I'm going to pick 2D elastic 3. Click OK, and as you see, a beam 3 element is defined for me. In the options, you may not necessarily have to concern yourself with, but you can define or change some of the options which are attributed with your element, or the element that you picked. I'm going to be okay with the default options. Click OK, and then go to real constants. Again, add, edit, delete. So there is no real constants defined yet, so I have to click add. And the real constants I'm going to define are for the elements that I just picked. I only have one element of beam 3, so I click OK, and this window pops up for me. Real constant set number 1. So if I want to add more than one beam, let's say I have just one element, but I want to have two cross sections for my beam, so I can define as many real constants for my element as I want. And when I'm defining my elements, then I have to be careful which real constant I'm applying for each element. For this example, to make it simple, I'm going to be defining just one real constant. As I said before, I want a cross-sectional area of 12 by 12. Here I can leave it 12 by 12, and ANSYS will do the calculation for me, or will multiply 12 by 12 and give me the result. Or I can also say 12 by 12 is equal to 144, so I can type it here. For area moment of inertia, I can say 12 by 12 by 12, because if you remember, when I calculated my moment of inertia, it turned out to be, area moment of inertia, it turned out to be 12 to the 3. I can do that, or I can say 12 by 144, and again, ANSYS will take care of the analysis or calculation for me. So I click OK, and I'm good to go. Then I'm going to material properties, and I click material models, because I'm not concerning myself with temperature units or electromagnetic units, because my analysis is not going to contain any temperature differences or electromagnetic forces. So I'm just clicking material models, structural. So if you remember, in the preferences window, I picked structural. So here I only have structural option. If I hadn't checked that mark or that box, I would see structural, thermal, fluid, CFD, blah blah, and it will go on. But so far, because I've only picked the structural analysis in the preferences window, only structural options is shown to me. I come to the very simple analysis, which is linear, again elastic and isotropic. And in this window, I can define my elasticity. I'm going to say 2E11, the scientific notion for 2 gigapascals. And for my Poisson's ratio, I'm going to put 0.3 or 0.3. And I click OK this window, and I have my material also defined. Now the next section is to do a modeling in here. I click modeling, click create, and as I said, because my model in here in this example is going to be very basic, I'm going to be just defining nodes and elements. So I'm skipping key points, lines, areas, and volumes, which in later examples I will need to define areas and lines and then do the meshing. But for this example, I don't really need to define any lines or key points, so I just define 5 nodes and active CS. So basically, when you click this active CS, you have this window, and you can define the locations in terms of X, Y, and Z, and based on the coordinates that you give, ANSYS will generate the nodes for you. And the first option gives you the node number, which you can leave blank. This gives ANSYS the option to automatically number the nodes. So if I say 0 and 0, because I'm doing a 2D analysis, so I'm not going to care about the Z coordinate. And if you see in here, this is Y in going in the vertical direction and X in the horizontal direction, and I'm going to define my beam in the horizontal direction. So the first node is going to be placed in the 0, 0, X equals 0, Y equals 0. Click apply. The second node, I'm going to say at X equals 1 and Y is still 0. You see I have 1 and 2 nodes here. The second one is going to be, or the third node is going to be at X equals 2. The fourth node is going to be at X equals 3, and the fifth node is going to be at X equals 4. And I click OK, so you see 1, 2, 3, 4, and 5 nodes. Now I have to define my elements. The first option in here is element attributes. As I said before, if you have more than one element, you can choose which element you want to attribute to your next elements that you're defining. If you have more than one material defined, let's say you have defined steel, aluminum, copper, I don't know, as many materials as you want, you can also choose which material you want to attribute to the next elements that you're defining. Real constants, again, if you have defined more than one real constants for your element, that you can pick them in here. The element coordinate system 0 is the default, which means the global Cartesian coordinate system. But if you had defined other coordinate systems, you could see them listed in here and you could pick them. In the section number, I didn't define a section or a target element, so I'm going to leave them as default. Click OK, and the easiest way to define elements for this very basic model is to go for auto-numbered. So I'm going to come here, and again through nodes. So if I click this button, come here, pick this node 1 and node 2, click apply, one element is made. Node 2 and node 3 apply element 2. Node 3 and node 4 apply element 3. Node 4 and node 5 OK, and my last element is generated. So let's go to the list and list elements plus nodes plus attributes plus real constants. See what happens. So right now I have the area, and so 1, 2, 3, 4 elements have been defined for me. Element 1, the area is 144, IZZ is 120,728, height is 0, and the others I didn't define really for this example. So all the elements have the same attributes because I only had one element, one real constant, and one material, so nothing has changed. And as you see, the nodes is node 1 and 2, node 2 and 3, node 3 and 4, node 4 and 5, which attribute the or define the beginning and the end of every element. I can also list my nodes alone, and this is it. My node 1 is at 0, 0, 0, node 2 is 1, 0, 0. So everything is listed in here. I can save them or print them, or so if I save them, it will be a text file, for example, somewhere, and then I can read that and convert that to an Excel file, which is more convenient if you have results read like that. So because I already defined my nodes and elements, I don't need to do meshing, because mesh is only for lines, areas, and volumes, and meshing for elements and nodes is not necessary, or you cannot mesh nodes and elements when you have already defined nodes and elements. So I can skip meshing part and jump into loads. The first thing I want to do is to come here and say new analysis, and make sure that I'm doing a static analysis. I'm not doing a modal, harmonic, transient, and other types of analysis, so it's okay. And I come to define loads and click apply, and definitely I only have structural analysis or structural loads and displacements. So the first one I want to do is define displacements on nodes. First I'm going to pick node 2, click apply, and say I don't want any displacement in X and Y direction. So I click 0 or type 0 in here and choose on UX and UY. Click apply. As you can see, this constraint is modeled in my node 2. I pick node 4, click OK, and say for this one I only want to make sure that there is no displacement in Y direction. So I pick UY and keep this equal to 0, and this one is generated in here, this constraint. And the next thing I want to do is to define a load on my node 3 in the middle in Y direction. I want to call -1000 and click OK. So my model is ready. I have defined my constraints at nodes 2 and 4, and my load is defined in node 3. So everything is ready to be solved. So I come to solution step, come to solve, click here in LS, asks me if I want to really do the analysis. I click OK. There's a warning which I can skip, click yes, and solution is done. Close this window. Go to general post process. The first thing I want to do is show you the displacement or deformed shape of my model. If I pick the first one, you will only see the deformed shape, but I'm going to pick the second option, which shows you the deformed shape as well as the undeformed or original shape. So basically this is the deformation of my beam according to the restraints and the load that I defined. We can also come to contour plot and go for example, nodal solution, and in a DOF or degrees of freedom, pick Y because I only have displacement in Y direction, or maybe I will have some X, but I will check. Click OK, and as you see, in the two ends I have the maximum displacement of 0.723 times 10 to the minus 12. So based on the material and the cross-sectional area and that I defined for my element, the displacements are very, very small. And again, this model was very symmetric, so everything is symmetrical. I can also do this to element solution. In element solution, you don't have displacement. So let's say I want von Mises stress in my elements, which is constant in the entire element because of the simplicity of my model. And then I can come to list results and read reaction solution. And let's say I want to read all reactions. Click OK. I only have two reaction points, node 2 and node 4, where I had defined my strains. Let's model my elements or nodes, let's say. Plot nodes and come to plot controls and numbering. Let's say I want to do number in nodes here. If you remember, in node 2 and node 4 I defined two restraints. Here ux and uy were 0 and here uy was 0. So I have an fy for node 4, fx and fy for node 2. But because I only have one load on node 3, which was in y direction, and everything is symmetrical, you expect to have two equal loads on in y direction on nodes 2 and 4, which is equal to 500. Add them together, you will get 1000, which is basically the same load that we applied in node 3. So I can save this one and then I can load that in Skype, in Excel later. I can close this and nodal loads, if I want, it will give me these things. Basically, what it's telling me that is that I have defined 1000 Newton load on node 3, so the loads on node 2 and node 4 are exactly opposite that, and there are some moments in these nodes which is very, very small. If you see, it's like times 10 to the minus 12, which is very, very negligible. And I guess for the first example or first tutorial, this should be enough to give you a grasp of how to run an analysis in ANSYS and do your modeling. This is the first lesson that I'm or tutorial or example I'm doing in ANSYS for you guys. I hope you enjoy this and this is useful. I'm going to continue giving more examples and tutorials, delving more into the advanced options and features in ANSYS. Feel free to give me comments and questions or ideas on the models or analysis that you want me to do, and I will try to cover the needs or requirements to for you to learn how to run ANSYS and do analysis in that, and how to get the results out of any analysis and modeling. With that, I'm going to end with the first lecture.